start off with our exponential equation. What's the equation that I gave you? B to the x, right? And what does A tell us? What does A tell us? Yeah. Initial value or starting value. Back row. Come on, get it together. What does B tell us? Not common difference, that's for linear. Common, says it over there on the sideboard. Common ratio, or what did you say, Elise? Growth factor, but I also just told you exponential equations don't always grow. They can also, what's the word we used? Decay. So growth or decay factor. Okay, so A, the number that doesn't have an exponent on it, that's our starting value or our initial value. And then B, the number that does have an exponent, usually it's in parentheses. I'm going to show you that right now, okay? But that B, the number that does have an exponent, that is our common ratio or our growth factor or decay factor, right? It's a growth factor if we're increasing, decay factor if we're decreasing, okay? And when we look at exponential relationships, a lot of these problems have to do with percents. We're growing by a certain percent every month or decreasing by a certain percent every month, okay? So I want to show you because percents are just a little funny. So let me show you this. Again, just a couple minutes of new stuff and then we'll take the rest of class to practice. So for percents, we can either be increasing by a certain percent or decreasing by a certain percent, right? I want you to read numbers 2 and 3 on your paper there. Read numbers 2 and 3. Tell me which number is increasing and which number is decreasing. Which problem is increasing and which one is decreasing? Read through. Yeah, perfect. Yeah. No, just on this one. Number 2, Sienna and the ant farm. What's happening to the population of the ant farm? It's decreasing by 2%. So when we have decreasing percents, the way that we figure out our decay factor, that B, is we start with 100% and then we subtract whatever amount it's decreasing by. So in number 2, the ant population starts at 100, is decreasing by 2%. So that means I start with 100 and I minus 2. What is 100 minus 2? 98. So that's like 98%. How do I convert 98% into a decimal? You are really multiplying or dividing, but what's like a simpler way to think about it? Point. Yeah, you just move your decimal point over. How many places? 2. Yes, right? 1, 2. So 98% is 0.98. 0.98. Okay? Now let's look at the increasing example. So in number 3, you're going to look at George's bank account, and George starts off with some money and then he puts it in a bank account, and it is increasing by how much? 2% as well. But for increasing, we start with 100% and we add however much it's increasing by. So we take 100 and we add 2, and what's 100 plus 2? 102. And then how do I convert 102% into a decimal? Move 2 points over. So what does it become? 1.02. Okay? So what happens when we do this, and at least this kind of answers your question, what happens is, so when we're increasing, we start with 100% and then add whatever the percent is that we're increasing by, right? So then my B, my growth factor, is always going to be larger than 1. It's always going to be bigger than 1. Versus when I'm decreasing, I'm subtracting from 100%, so then my factor is less than 1.
So the growth factor will always be over 1?
So the growth factor will always be over 1. The decay factor will always be less than 1. Does that make sense? So the number in our formula, whatever this is, if it's bigger than 1, it's going to be an increasing relationship. If it's less than 1, it's going to be a decreasing relationship. Simple as that. Okay. Let's pause. Okay, so we're looking at the Thursday paper. So first thing, let's read through the problem. If you buy a house for $130,000, it appreciates 6% per year. How much is it going to be worth in 10 years? So let's do this together. First step, is this growth or is this decay? Growth. What does appreciate mean? Good question. Let's talk about that. So on the other paper we had the car loses 1/10 of its value or something like that, right? When you buy a car, unless you're buying like a Ferrari or something, or like an old Corvette or something like that, like a collector's car, that car just decreases in value over time. You can buy a brand new car, and the second you drive it off the lot, it's decreased in value immediately. Yes, because it has miles on it, and like obviously, like the more you use a car, the less valuable it's going to be. That makes sense, right? Just the same way as you could go and buy a brand new pair of like Nikes, and they're like $200. If you go to a thrift store and you want to sell them to someone else, no one's going to pay $200 for old Nikes unless they're like, again, collector's items or something like that, right? Most things that we buy lose value over time, right? That makes sense, yes? Your iPhone, I don't know, what was like your first cell phone that you had? Yeah, an iPhone 6. What's an iPhone 6 worth now? Hardly anything. Maybe you could get $50. I don't know. Maybe. Maybe. But anyway, there's something that you can buy that almost always increases in value.
Toys.
Houses. A house. A house appreciates. So appreciate is that it's increasing. Depreciate is the opposite way. It depends, right? Like, did you guys hear about the train in Ohio that like there was like a train that derailed and they like spilled a bunch of toxic chemicals? Those houses in that town are depreciating by a lot right now.
I have a project.
Charlie, you got to do a problem before you leave.
That'd be something you'd want to buy. Buy that land and then wait.
Like 300 years until those toxic chemicals go away, right? But you know what I mean? So most of the time, like right now, the houses in Montezuma County are appreciating at like a pretty high rate. Because people from California, people from Denver, people from Texas are all moving here. That's increasing the value of our houses. But anyway, this is appreciating. This is increasing. So that's your answer to the question.
So it's increasing.
Increasing. Good. So is it? Did you do the top right corner?
Yeah. You did those as
No, not one. Well, that one already has an answer to it.
It'd be 4.
4 to the first. Do that top right corner one because that one's not right. The X to the 5th looks good, but what do you need to do with your 2's? Top right corner. Yeah. What do you got to do with your 2's there? 2 times 2 gives us 4.
2 times 2 is what you're
Yeah. So 4 And then what do you do with your exponents on the x's? Yeah. Get your x there. Get your x there. Good. There you go. Thank you. Good job. 2 times 2 is weird because it's 2 times 2 is the same as 2 plus 2, which is the same as 2 squared. I have one, you know, the meme of the Spider-Mans all looking at each other. I have one that I'll show you in a second. Yeah. But anyway, appreciates means growth or decay. Growth or decay? Growth. Good. What is the initial amount of the house? 130,000, right? And what is we already decided this is a growth rate, not a decay rate. And what is that percentage that it's increasing by each year? 6%. But what do I have to do to actually make my growth rate? It's not just 6%. I got to add that 100%. So what's 100 plus 6%? 106. And what is that in decimal form? Perfect, 1.06. Okay, my growth rate is my B. My initial amount is my A. My equation is y equals AB to the x. So what is my function that represents this situation? Yeah, write the whole equation out. Replace 130,000 for A. Replace 1.06 for B. What's my equation going to be?
Y equals 1,300,000 times 1.6.
Y equals 130,000 times 1.06 to the x. Perfect. But now, how am I going to figure out how much it's worth in 10 years? What do I do with that 10 years? What am I going to plug it in for?
X.
X. For that exponent. That exponent we replace with 10. So I'm going to get, let me write it down here. So y equals 130,000 times 1.06 to the 10th power. And that's what you plug right into your calculator and out pops the answer. Let me show you. Let me show you how we put it in. So I don't have to put in the y equals, obviously, right? I just plug in the numbers. So 130,000 and then parentheses 1.06. And then for the exponent, we use this little triangle upward pointing arrow caret thing.
Where is that?
It's right here under the clear button. So up to the 10th power, that's what you should get. Yeah. So in 10 years, right, they gained $100,000 on their house. They basically made $100,000 by just living in their house.
Would it ever decrease though?
It does decrease sometimes, yes. Like I said, if something were to happen, like I told you about the house in Ohio, right? That is